Hey guys, and welcome back to my channel. And today we're going to be talking about stack. Now, stack is a linear data structure just like arrays, but the way you're accessing the elements and the way you're retrieving data from it differs a lot. Like, for example, let's talk about stacks. When I'm talking about stacks, before moving on, let's talk about a scenario. Over here, let's say I'm having a table. Imagine it to be a table. I guess I'm doing pretty good. Okay, this is a table, and you got some plates to stack on it. So you take your first plate. This is your first plate, and I'm trying my best to visualize it for you guys. So this is the first plate, and this is the second plate, and this is the third plate that you're keeping on the table, and this is the fourth plate you are having it on the table. Now, as you can see, there are four plates stacked on top of each other in the table. Now I'm telling you to take one plate out of it. I want one plate out of it. Now, how would you take it off? Like, how would you take the plate? It's very simple. First, you would remove the top of the plate and give it to me. And once you remove this plate, so let's say I'm so sorry. You remove the top of the plate and you give it to me, right? And then we remove the third plate. Oh my god, it's messing up. And then we remove the third plate, and then you would remove the second plate, and then the last plate would be removed. In this case, if you have noticed one thing, that the first plate we kept in the table is the one that has been removed last, right? This is the first plate. While I'm placing it on the table, it was the first plate. But when I asked you to give me each plate to me, you gave the first plate as the last plate. And also, another observation, the last plate, which was placed on top of the table, was handed over first to me. Okay? First to me, right? To make it more simple, the last plate was on the top, and whatever you placed first would be at the last. So there are two ways that you can implement um, your stack. One is using arrays, okay, and the other one would be using a linked list, right? So before we look onto the implementations, this is a static way of implementing arrays, and linked list is a dynamic way of implementing stack. And also, we'll be looking at some operations on the stack. So the basic operations that you can perform on your stack would be two things. One is a push, and another one is a pop. Now, these are the basic. You do have a lot of things. Now, what is this push and pop? Okay. Now, push means the process of adding a new element to the top of the stack. What do I mean by that? So over here, we got a stack. Let's imagine it to be a stack. Stacking, like you keep the elements on top of each other. So this is how you would do it, right? Push is very simple. It just means that you add a new element, okay, on top of each other. So for example, let's say this is a stack. You add an element 8, okay, just the data, just adding a data to it. Now the next data would be on top of it. The next data would be top of it. And the next data would be on top of it. Now, what is the difference between a stack and an array? What is the difference between both? One of the most major difference between a array and stack is that how you access your elements and how you get to the elements. For example, let's say 1, 2, 3. You would easily have a random access if you want to. You can just use array of I, or I mean array of 1, and you simply get the element 2. But let's say when you want to go and access an element on a stack, just like we did for the plates. For example, let's say we had plates here, and remember there are lots of plates. I mean, you cannot straight away go and access this randomly, as there are a lot of plates stacked. First you have to remove the top, next you have to remove the next one, and then access the third plate. So this is the major difference between an array and a stack. For example, in numbers, imagine this is a stack and let's have it 8, 9, and 10. And let's say you want to access the element 8. You have to remove this 10 out, you have to remove this 9 out, and then you can access this 8. So once you remove 10 and then 9, and then you can access 8. Let's talk about pop. Now that we have discussed a little bit about the difference between a stack and the array, pop is nothing but removal of your elements. Yes. So the pop is process of deleting an element from the top of the stack. Remember, you'll be um, removing these elements from the top. Okay. Now coming back to the implementation that I've already mentioned about arrays and linked list, there will be a little bit doubty for you guys. What is a dot? How would we implement this behavior, the stack behavior, in the arrays and linked list? Let's have a look. Stack is a data structure, linear data structure that follows LIFO, which is last in and first out. That means whichever element that is placed at the last will be the first one to go out. For example, let's say this is the first element I'm placing. This is the second element, and this is the last element that I'm placing inside our stack. You can see that this element will be the first one to get out. So first you remove 20. So last in and first out. So the next number after you remove 20, it would be 10, and then it would be 18. Now this is the last, it's on the stack, so this would be the first out, and then 10, this is the last number, so first out. Okay, so now there are three things you need to know whenever you're trying to implement a stack using arrays. So when I say that I want to implement my stack using arrays, that means that I'm going to be using an array here, okay, to store the elements, and that goes to the same way to linked list. I'll be using it as a storing part. Now to implement the stack behavior, where I want to make sure that the behavior is actually resembling a stack behavior, that would be using a variable called as top. Okay, so this is the variable that would help me to keep track of the elements and would make sure that the access is not index based or memory based. It's based on just a single pointer that is a top. Uh, you will see this when we're trying to implement the details onto the data structures like array or linked list. When we're using it to implement the stack, you would clearly see why this top variable is being used and what role does it play here. Now another one other variable that we'll be using, these are variable names, to be very clear. It isn't too complex, I want to say. And then the size. Okay, so when you are creating stack, see capacity, as long as you're using arrays, you would need size. So what do I mean by size? For example, let's say inside a stack, you would be, it's same as if you're going to be implementing it using arrays, it's going to be as similar to an array, right? So whenever you are saying that I need a stack to store my elements, initially using an array, initially you will be creating an array, and you'll be also making sure that you're creating it as long as you want, like a fixed capacity, because you're using a static implementation where you have six fixed size. So let's say I want 4 elements inside my stack. I would be creating an array containing size of 4. And then I would be inserting my elements one by one. Let's say I first insert 1, and then I would be inserting 2, and then I would be inserting 3, and then I would be inserting 4. Now coming on to accessing these elements, okay? Let's say that my stack would look like this. At first, you would have 1, and then 2, and 3, and then 4. This is just a visual representation of how my stack would look like. And then I'm going to have something called as top variable. This top variable will be indicating the last element that I've pushed onto my stack, or in other words, I have added into my stack, the last element that I've added. So top is the pointing towards the last element that I've added onto my stack, right? Now, this top is, you can just say, hey, wait a minute. Why not let's set top to the size of the stack? Why not do this? I highly recommend not to do this, because who would say you that you will just implement, you will just make a size of stack of 4 and then insert just 4 elements? No, some people would just add 3 elements. That's how stacks work, right? You don't really need that much of capacity. We'll have a look on to, as we come to linked list, you will be a lot clearer on the size part. But for now, this is the wrong practice. Don't ever do this. Don't ever do this. Okay? It doesn't justify the behavior. So basically, you just need to make sure that the top is pointing towards the very last element. Now the behavior comes to play. How would we use the top pointer to exactly stimulate the behavior of a stack? So basically over here we have top pointing towards the last element. Now let's say that it doesn't point towards this element. Okay? Top doesn't point towards this element, meaning that it doesn't really remove the element, but it does not point towards it. Okay? So let's say top doesn't point towards it, and it starts pointing towards this, right? So that's what it does. Okay? We just move the top pointer. So we point towards 3, indicating we remove the topmost element, right? But in reality, we're not deleting that element, we're just moving a pointer, or we're just pointing towards this element, okay? The value just stays in the memory, but you cannot access it. That's it, okay? That is the whole point of it. Now, I say that I want to remove this element as well, and then I just move the top pointer towards this, indicating that only this part is accessible and these are not, indicating that they have been deleted. But in real, they're not deleted. They're actually still in the memory, but we're just not allowing the access towards it. That is it. Okay. Why don't we remove it? Because removal is completely unnecessary when it comes to implementing a stack using an array. For example, let's have the first element inside of our array is 10. Okay. Now the top is going to point towards it, because this is going to be the last element in the stack. Now, if you're adding another element, then we can just move this top pointer here. But for now, top is representing 10. Like, it's pointing towards 10. Let's say this operation is called push. Okay, we just pushed an element onto the stack. Now what I'm going to do is I'm going to pop up this element. So what I'm going to do, I'm going to perform a pop operation. And what I'm going to do is I'm going to remove this completely. So removal means I will just move my pointer away. So top pointing towards at 0th element would now be -1, because I'm no longer pointing this. So I'm just decrementing it because I'm not pointing towards it, and top moves here. So it's like Now top doesn't belong here, and it just moves here, right? It just moves. It isn't belonging to the array anymore, right? So yeah, now top doesn't belong here, and we are going to pop. So this is what pop literally means when you're doing an array implementation. Now this 10, now will still remain in the memory. Let's say I'm going to push now. Let's say I'm going to push an element now. Now what happens here, let me push 20. Okay, I'm going to push 20 inside this array or stack. That's actually a stack. Okay, so what will happen? This 10, this one will be overwritten. So I'll override it to 20, and top will be pointing here now. Okay, so basically this top determines the array's position, where it needs to be inserted, or the deletion and everything using the single pointer, because that's the whole point of view. Okay, to be more precise on what I'm actually doing here is very simple. So you take an array, and this top is going to be where your element is going to be. Okay, so if array top is 0, then that is where your element will be. Okay, if you're pushing. Now let's say you're going to have push another element, it's going to be determined by the top. How it's going to be determined by the top, we'll be doing top plus plus. Okay, and before inserting as well, we'll be using top plus plus, so your position is determined by top. And also top will be pointing towards the very last element. So right now top would be pointing to the first element, right? So top would be pointing towards the first element. So can you imagine? Can you see over here? The top becomes only 0 here. So what would be the initial value of top? What would be the initial value of top? It's very simple. So top's initial value would be -1. So that when you're starting to push an element inside of this array, it would actually go and sit in the first block. So it will be array of 0, and then an array of 1, the next element would be stored. How would a push operation be looking like now? Like pop operation. So when I'm talking about a pop operation, that would simply mean that I'm doing top minus minus. I'm no longer pointing towards that element now. So for example, if array of 1 has array of 1, now when I do top minus minus, I no longer point towards this element, and right now top would be pointing towards 0, the 0th element. That's what we want, right? So we're going to be implementing a stack right now using arrays. So first, I'm going to have a separate class over here that names a stack. This is just going to be basic implementation. You can just use maybe you can use private variables if you wish to. So first, I'm going to have an array, and then we're going to have a variable called as the top. So I'm going to have top, and then I'm going to have size. Okay. Now I'm going to have a constructor so that I can just initialize the values really quick with the constructor if someone is creating an object using this. So this is our constructor, and the thing is, I just want the size of my stack. I don't want any other details. And use this dot size is equal to size. Now you do need to initialize your other variables inside your stack, or you can just do it. But it is mandatory for you to do it initialization of this array inside the constructor. That would be very easy to do, and also you will get the size inside your constructor itself, so you can just do it inside your constructor itself. So once a stack is being created, a stack object is being created, you do want your array to be on ready, right? So let's do an array is equal to, and then new int size, right? And then you'll be, sorry, top variable to be initialized to -1. Now another way that you can do this array is you can initialize it in your main function and then just, you know, like pause onto it every single function that you're using. So we don't want that to happen. So like we're just gonna have this array um, initialized inside the constructor itself, and make sure we're having this array within our stack class itself. Okay. So now what we're going to do is we're going to implement a few operations. Now these operations are way more simpler to do. The first operation that I'm going to do is called push. Okay. I'm going to do a push and then I'm going to do a pop. So let's do a push. Now, what do you think would be the return type of this push? Just think about it. Would push return anything? Nope. Why? They just not they just not return anything. Basically, they're just there to insert an element inside the array, right? So you just want your array to have an element, right? So what do you want to pass inside? Let's say any kind of data. It can be int, string, a boolean value, whatever, just data. Okay. So we're gonna push. What we're gonna push? A value, right? Make sure you do top plus plus because your -1 is doesn't want, you know, something to be unaccessible to the arrays. Make sure you top plus plus and then do array of top is equal to the data. So in this case, let's say array of 0 will have the value 10 if this has the value 10. Okay. Now the next thing that we're going to do is a pop. So void pop. And now the pop, sorry, it's not a void function. It's actually going to return something. Now sometimes people do want to see what element is deleted. So we do return it in case we want to use it. And mostly pop does return value. If you're taking an inbuilt function of a stack, pop returns the value, and this is used most of the problem solving methods. You do use pop. You do want the element that is currently being removed. So we do return the element as well. Now, how do we know what element to remove? As I already mentioned, top will indicate the last element, that it will point to the last element that's on the stack. And pop does the simple work of removing the last element. So I'm going to go ahead and say a value. Now you top, and make sure you do one more thing before returning the value. You do decrement the top value, okay? Because it's now removed and it needs to point to the next last element that's on the stack. So make sure you decrement your value and return your value. For example, we have a stack. At first we inserted 10, and next we inserted 20. Now I want to remove this. Now top would be pointing over this element, so this is where top would be. And then when I do top minus minus, it would just go ahead and point towards this. Okay, it will no longer point towards this element, but it will still remain in the memory. I mean, 20 will be there, but top will no longer point over this, and 20 will be returned over here. All right, so this is what we're doing in this operation. Now, there are some constraints that you need to notice over here. Now, that will be done. I will show you what are the constraints we would be getting. Okay. Now, what I'm going to be doing is actually pushing elements. So stack s is equal to, I'm sorry, new stack. Okay. Now over here, I'm going to be calling this one. Now there are some other functions too, like is MTP, is full. Looking onto those as well, so don't need to worry. So first, I'm going to push on to some elements. So let me push 10. Let me push 20. And before running the program, I just want to make sure that everything is working well and good. So we do need to print the top value at every point so that we can see how much the top is moving. And also, I need to send the capacity over here, or the size. You can see over here that we have initialized it to. So let's send maybe 5. Okay, now let's run the program. I don't know. You can see over here that this is the values of the top. So the top is working fine. Now let's try to pop these elements. And also, let's check out if this is returning any value. Println. So I'm going to put this pop inside this one. And now let's just run the code so we can see that if 20 is being removed. And also I want to share with you guys the current as top, then what the value of top should be at 0, pointing towards at 0. And you can see that's currently pointing towards 0. And over here, let's start looking at the constraints one by one. So the first thing that I'm going to do is I'm going to pop the remaining element as will. So let me run the code. Let me pop that element as will. And you can see the 10 is being popped off. So now let us check the value of the top element s.top. So if we just go ahead and check the top element, that would be -1. But what if I try to go ahead and pop the element now? What would happen? Let me run the code. And you can see over here that we're getting an error. Index -1 out of bound lengths. We can't really pop off any elements because there are no elements to pop off. And when did we get this error? We got this when our top was -1, right? So what we would do to handle this is basically we would go inside our pop function, and basically before we interact with the main problem, we would just check if our top is actually -1. If our top is -1, I would literally just do this. I would go and say that you can't delete because stack is empty. That means if your top is -1, you don't really have any elements, and I don't want this to continue proceeding, so I just return it back to where it's being called. And now let's try to run the program, and it will just run again. And now you can see, oh my god, missing return value. Maybe we can return, yeah, we can return like so I'm going to return -1. Now let me run the code again. And now you can see over here that we're not getting anything because you can't delete because stack is empty. And this -1 is appearing because I just, printed the value of what it returned. And now what we're going to do is I'm just going to go ahead and do another thing. That is what I'm going to do is I'm going to add some elements on here. So let me just so we're going to push some more elements. So let's push 30, and let's push in 50, and let's push another element, just 40. All right, and then let me run the code. Now you won't really have any errors going on. These are all pushed successfully. Now let me just go and push 60 over here. And when I try to push 60, you can see there is an exception because out of bound, there's no space to actually insert. So we'll also write a code if your top. Now you can see over here, why do we get this exception? Because top value was out of bound. That means top was way more than this. So to avoid it happening, we first check if top is actually reached the size, and if it did, or top size -1, because it's stored in an array, and array indexes are 1, 2, 3, 4, and 5, where we would get 6 elements, and top is equal to size -1. You can simply say to the user that stack is full, right? And you would just say return for this. Since there's no return type, I'm not returning anything. Any number are just going to return because it just want to go back to the place where it's being called. And you can see here that stack is being full is what the message is getting printed on. Now there are some other functions such as peek and also is empty or is full functions. Now just to get a little bit more of what is peek is you can see the last elements that is inside the stack, or the element that's being pointed by top, or the topmost element in the stack, you can see. And is empty is something to make sure you know whether the stack is full, is empty. That means it's very simple. You just need to have your top equal to -1. If it is not -1, then it's not empty. It's a Boolean function, so I guess. And is full is as well a Boolean function. You can also print messages if you want. You can have a void function and just, print it. So if it is full, you can say that stack is full. Okay? That means top has reached size -1. Now these conditions have already been given over here at the pop, as well as to the top and top, as well as to the pop. And in other words, you can say that stack has been overflowed. Stack overflow. And you can say this one as stack underflow. Now I hope these things you can do it. You can see the last element that's being pointed by the top without actually deleting the element. Okay? You don't need to delete just to have a little bit of sneaky peeky on what is there. Okay? And it's very simple to implement it. So you just need to have int peek, and what we're going to return is the topmost element. So we're just going to return what's on the top. And you can also use is empty over here. Like if it is empty function inside of the if condition, so that you can check if it is empty or not. And you can also use is full inside this if condition to check if it's not. So let me just quickly show you. Out.println. Let me show you as.peek. You can see over here that it's pointing towards 50. Now if I just remove an element, it's going to point towards 40. You can see over there. Now we're just going to do the Boolean functions. So I'm going to do Boolean is full. I'm going to do Boolean is empty. These are not the best practices, but yeah. Yeah, so then we just check the condition. So I'm just gonna. So if it is full, this is the condition we want to have it. So if top is equal to size -1, And then we're just going to return if it is full, we're going to return true. Okay? And if it is empty, we're going to take this one. Top is equal to minus 1. And we're going to return true as well for this one. Now, what if it's not? Then we would return false. And what if it's not top minus 1? We would be returning false as well. And yeah, so next we're going to just go here and we're going to change these conditions. We're just going to do a function call is empty, and for this one we just need to check if it's full or not. It's full. So now let me just run the function really quick to see whether it works. So here I'm going to push an element. Let me say 60. Let me run. And you can see over here that the stack, and we'll just check the function for stack.pop. So what we would do is we'll have only 2 elements, maybe just one, and we'll just pop and pop again. Let's run the code. You can't delete because stack is empty, but we do got exception like index -1 out of bound. Right. Now the exception I got is because of the peak function. The reason over here you can see I'm trying to print the peak element, and you can see over here that inside the peak we didn't really add the condition for it to be checked whether if the stack is, empty. So what I'm going to do is I'm just going to copy this exact thing, and yeah, the stack is empty. So you can just say stack is empty, and now you will not get this exception again. You see here, you can't delete because stack is empty, and then when you try to access the peak element, stack is empty, and it return -1. Now this linked list, stack using linked list, is what inbuilt stacks really use. You don't really specify the size, and you can just add as many elements as you want onto your stack. So cutting down to one of the conditions of being stack overflow. But you may get an underflow. I mean, you may get an underflow, which means your stack might be empty and you try to delete an element from your stack. It might not be possible because, as I still told you, that you can't delete an element from an empty stack. So that might be the only condition that you need to check whenever you're trying to implement it using a linked list. But it's way more better than using an array, because when you're doing with an array, the size is the exception here, and over linked list, size is not exception. You can create as many elements as you want. You can push. There is no constraint for that. Now there are 2 ways that you can do linked list. One, you can create your own linked list class and then implement the stack, or you can do an array list. You can create an array list and then do it. Now there's 2 ways, but today I'm going to be discussing with you creating an actual linked list node and doing it. So this is how a linked list is represented as. So in this we have the data, which stores the actual value of the stack element, and we do have the address or reference to the next node, and this is how the nodes are actually connected to each other. So basically you have a data, as well as a address to the next node, connecting to the next node. Okay. Over here, top would be the last element that gets inserted, right? And this goes the same. But over here in the linked list, how we'll be inserting the elements. In a linked list, there will be two types. One is the data, and next is the memory that helps us access the next node, right? In a linked list, the representation would look like this. At first, 10 would be the first element getting inserted, and then 20, and 20 points towards 10, making 20 the current top. At first, when 10 is being inserted, top would be pointing towards 10, but next when 20 is getting inserted, top would be at 20, and when 30 is being inserted here, this would be top. But as per the diagrammatic representation, you can't pre-create your nodes. Your nodes would be created at the time you are inserting an element. So for example, at first I want to insert an element at first, let's say 10. At that time, this node would be created and 10 would be inserted inside this node. And let's say next, I want to insert 20. This is the next element I want to insert, and 20 would be inserted over here. This 20 would be pointing towards this node. And then 30 would be inserted. So I would have to create a node. And then 30. So this is how the actual creation of process goes. So as you try to insert values, you create nodes. That's why you do not need a fixed size. Now to get a more of a picture of what we're going to do and how we're going to make the code and stuff, we just need to know some more stuff before we hop onto this. The first thing that you need to know is what the top is going to point to at. Okay. The first thing you need to know is the top is also going to be a node. So there is no doubt the top is going to be a node as well. Okay. Now here you do need to point towards a top as we, go through these elements. Okay. So first, let us see what happens when we just insert one element. So first we create a new node whenever we want to insert elements, right? And also we need to make sure that this element is currently pointing towards null. That is also something that we need to make sure that we're doing, right? And of course, whenever you create new elements, they're going to be pointing towards null, okay? But when I'm taking up my next node, when I'm trying to insert my next node, I need to make sure that this second node is actually pointing towards the top, right? And then I need to make sure that once this element is being inserted and got pointed towards the top, I need to make sure that top moves to this. The top doesn't stay here. Now top is here. Okay? I hope you're understanding what I'm talking about. So what I'm gonna do is very simple. So first I'm gonna have um, a node. Okay? Now this node is going to be null at first. Okay, when I'm actually creating it. Now first the top is going to point towards this node. Okay? And top is also a node, but also remember that I need to do something. Top is a reference node. Okay, top is just a reference. I mean, it's just like a pointer, but it doesn't actually. Okay, we do not use like a new node. We do not create it as a new node. Okay, and you need to be very, very clear with this. Like, top is not a node. It's just a reference or a pointer to your node. Okay, node is actual box memory. Okay, but top is just a pointing to a box, like pointing to a node. Okay, it's not the doesn't have any data. So when I say that having node means you should have a data inside of it, but top is not having any kind of data. It's just a pointer. It's just pointing towards your element. Okay, it's just a pointer or a reference that is pointing to. Okay, like that. So top doesn't store any data. Okay, it just points to where the top node is. Okay, it's just a reference variable. It just holds the address or the reference of your node object that it's pointing towards it. Okay, if top is at 10, it's gonna hold the address or the reference of that node object. Okay, so make sure you know that. Okay, so whenever you push, you create a new box and link it to the old top box, basically to the new box. Okay, so to be more precise, you whenever you insert a value, you create a node here, and now what you do is you try to link it to the old top box. That means you need your next to point towards the whatever the top is pointing towards it. Okay, so right now the top is at null because the top dot next is completely null, so just point towards null. Okay, now the top is referencing, or it's having the reference of this 10th one. So whenever 20 is created at first, the 20 is going to have null value. That means it isn't going to point towards any of the nodes. So what you would do, you would simply assign it top dot next. So when you do top dot next, okay, or top, you just point towards the top. Okay, don't do top dot next. You just need to do it top. Okay, so that this new node points towards the top. Okay, so when I write code, it will be more and more clearer as we write code. Okay, so these parts might be a bit challenging or might be a bit newer if you're not having the basics of a linked list. I've tried my best to explain it, but I do not know how much you have gotten it. So yeah, let's just jump right onto the code. At first, I do want to create a linked list, so we need a node, right? And what do the node has? A data, and you can have a string, you can have a character, you can have a boolean data. It doesn't matter what your things has. And then we're gonna have a node next. Now this is where it stores the reference, okay, or point to the objects. Okay, so it's just like pointing towards objects. And the next is going to be a constructor to initialize the values inside your nodes. So when I mean it is actually data and data equal to data. And whenever you create a node, it should be null at first. That's why we give this, right? Or you can just give next. It doesn't matter, right? So the code of return is really important because it helps us to create a node. So whenever we give new node and create it, it will first create as a data, and it will create a next where it's like a pointer to the object. I mean, pointer towards the next node that we need to connect on. So basically, it's simply like an array, but the memory is not contiguous, and it's just random. And you can access one element to other element using this pointer only. So it's really important to give node next. So now it's time to create a stack class. So I'm gonna create a stack. Okay. And inside the stack, we're gonna have the first thing is top, okay? Not integer, okay? Like it's not gonna be int top. No, 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 I don't want you to do this, okay? Don't be on that array. It's gonna be a node. And this is gonna be just a pointer or a reference where it stores actually the address of your current pointing object. Okay, it isn't going to have the actual data, but it's going to point towards the object. It's going to show you guys, hey, I'm right in this data. Okay, that's what the top is for. Now you can't do top plus plus or something like that to move it, so we'll show you guys how to move it and stuff. Okay, so this is going to be the reference to your top node. The next we're going to do is a constructor, and for this constructor there's just one line. Okay, it's actually the code is way simpler than you would do in an array. The code is very simple. So basically, you're just going to have a stack, and what you want to do is initialize it to null. Okay. Now, even if you don't do this, it's by default it's null, but it's for safety purposes. Okay. First, what I'm going to do is I'm going to push an element, and as we already know, that pushing will not going to return you anything. It's just going to insert data. At first, you need to remember that it's a stack and not an array. So this stack, how do you insert data? It's very simple. You just take your node class and you need to create an element over here. So I'm just gonna name it new node, or for simpler, we can have it as element as well is equal to new node. So this is how you create your node over here. So when you do this, a node like this will be created. Okay. Now, when you go and insert values into the constructor, it actually inserts the value. For example, if I give inside the constructor, if I give a 10, it will insert a value called 10, and the next will be pointing towards null. Okay, so this is how it will look whenever I try to create a node. So over here, I'm gonna get my data. So it can be a data or an X, whatever. Right. So once you create a node here over here, now this doesn't stop over here because you need to start linking the element. Now the top should be pointing towards this element. Okay. So what you can do to make the top point towards this. So when you try to link top to the element we just created, what mostly people think we can do is we can simply take top and just give new node. But people sometimes forget that we need to make sure at first we make sure new node is connected to top. So let's say 10. At first it should connect to the old top, and then the top can connect to the new node. So this is the first thing that we need to know. And you will come to know this whenever we start to add new elements. So what I'm going to do first is I'm going to link my element dot next to the top, and now I'm going to take top to new node, or let's say an element. Okay, it's just a practice, the basic practices of typing new nodes often. Let me show you why this is really important. For example, let's say at first we created 10, and now this is pointing towards null, and the top is pointing towards this. So next, let's say I'm inserting a new element. This is 20, and this is completely null because it's the new element we're creating. And now I want to point this to this. That means if top is the only way I can do it. So this element at first will point towards the top, and then this top will point towards the new element that we just created. Okay. Now I hope that was a bit clearer. Now let's go to pop. Okay. Now, as I mentioned already, we do need to make sure that we don't unnecessarily pop elements on an empty stack. So to make sure that our stack is empty or not, we would be writing is empty function as we did earlier, and we can do system out println and print out that stack is empty. And also to stop further processes, we can return -1 in this case. And also remember that to read top element, and we need to move the top element as we did for array. Okay, as we did for array, and also make sure that you do return the top value. That means you do need to return value that, like you did for array. So make sure you keep your value ready. So how do you do that? It's simple. Top.data. As top is referencing to the current element, so top.data is something we do. Now, this is a very simpler process when I talk about moving the top reference. Okay. So for example, let's say the top is pointing towards 10. So top.data would get 10 for you because it's pointing towards 10. It's simple to get the data from there. Now there's one thing left to see for us, that is how to move the top pointer forward. So it doesn't really delete it from the memory, it's just dereferencing it. So what we do is, for example, let's say 20 is pointing towards 10 and we do a pop. Now what we do is we dereference 20 from 10. Okay, so 20 should no longer point to 10. So we're cutting down the memory from it. So basically there's just going to be 10 left. So top should go back to 10. Top should point back to 10. It's very simple to do that. So what you do over here is you need to remember that top is pointing to 20. Okay, to 20. So if you do top dot next, which is 10, so top will point to 10 now. Okay, so what you need to do, top is equal to top dot next. All right, so now we've done this. It's very simple. So top is pointing towards 20, and this is now pointing towards 10. So when you just do top dot next, top simply dereferences it and start pointing towards this. But you should also remember that 20 is still pointing towards 10, but we don't really care about it. We just care about the top variable because that's what we're actually using in the programming. That's what we're using in programming overall. So it doesn't really matter as long as things work well with the top. Next, I want to talk about is the peak. Yeah, the peak, and then and then we'll just write if it's empty function. That's pretty easy to write. So the peak element is gonna have some few lines over here. It's very simple. You just need to return top.data. So it's as simple as that. It's the same thing that we do with the array part. So what I'm gonna do is I'm gonna create int peak. It's the same, guys. You just need to return the top.data, and over here you delete it and then return it. Over here you just return it. And also you need to check if empty function as well. And we'll just say system.out.println. Another thing is and we'll just say it that stack is empty, and we'll say return -1. So I'll just write is empty function. So we'll write it over here. So is empty is a boolean function. Now this boolean function, if your top is null, that means it haven't have any values inserted. You can see that the top is null. You can say that return false, otherwise we return true. All right. Oh, sorry, just the opposite. True. Otherwise, it's not empty, so false. Okay. So now let me do the main function and test whether the code we return is correct or not. I'm so sorry if I did make a mistake. I don't know if I did everything correct or not. First is I want to create a stack. And then I would do a element push, and let me print out. I don't even know what to print out. I mean, I don't know, guys. Let me just print out peak, maybe. Yeah, let me run. You can see over here that the top is pointing towards peak. Now let me push 20, and let me help you guys see what is inside the peak. And you can see over here that it's 20. Oh yeah, that is ln 20, right? Now I'm gonna pop, and then I'm gonna show you what's the top element. System.out.println as.peak. Let me run the code, and you can see the peak would be 10. Okay, because we just popped off. Now I also want to tell you guys this one. After we push in 20, you can see that s dot. I don't know if it really will show you. S dot next. I mean s dot next. I don't know if it will show you. Cannot find symbol. Okay, yeah, you cannot find the symbol because it's not in the stack, it's in the node class. Okay. Yeah, just wanted to try it out to show you guys the reference part, but yeah, that is it for the video. And also I'll just show you guys. I'll pop it again, and then I'll show you how the constraint works, the if condition works or not. You can see stack is empty. So thanks for watching this video. It's a pretty long video, and I'm sorry if the video was slight disturbances in between. And I hope to post more videos. Thanks for watching.